algebra students, tonight's lesson is on finding the zeros of your quadratic equation. Our objective is I can graph a quadratic equation using key attributes. These attributes include finding the zeros of a quadratic equation using three methods, including the square root property, factoring, and the quadratic formula. As a quick review, quadratic formula equals negative b plus or minus the square root of b squared minus 4ac all over 2a all over 2a. Do you remember the song? Okay, so good news. Tonight should be mostly review. Okay, key terms, words used to describe values for x that tell you where your quadratic function crosses or intercepts, fancy word, intercepts the x-axis. Now there's a lot of different ways they may ask you to do this process, so it's going to be helpful if you can identify all of them. They may say find the zeros, they may say find x-intercepts, what are the solutions for, or what are the roots of this equation. All of those methods are asking you to find where your parabola crosses the x-axis. A lot of times they call them zeros, because when y is 0, what's x? That's how you figure out your x-intercept. Quadratic equation in standard form, remember, where we get our values from, our a, b, and our c, is if it's in this form, ax squared plus bx plus c. It might be set equal to 0, it might be set equal to y or something else. But notice that all three of those terms have to be on the same side of the equals, and then we can move from there. Three possible outcomes when you are graphing quadratic equations. You may cross the x-axis twice and have two solutions. Or you may come up, touch the x-axis, and go back down. In this instance, you have only one solution. Or you may not even touch the x-axis at all. And in this instance, you have no solutions. Okay, so sometimes it'll help us graph, sometimes not so helpful, and we'll have to look at other information. Okay, part A. Find the roots or solutions by using the square root method, which are graphed as x-intercepts of the parabola. Okay, first one, number one. Now we've solved problems like this before, so I'm going to go through this kind of quickly. To get rid of an x squared term, it's isolated. We take the square root, both sides. But remember, when you're taking the square roots of both sides, you have a positive root and a negative root. So you always want to throw that plus minus in front of your square root sign. So the squared root and the squared term cancel each other out. You have x equals plus or minus the square root of 64, which happens to be a perfect square. The final answer would be x equals plus or minus 8. Or you could write it as two separate terms, x equals negative 8 and positive 8. And when you go to graph your parabola, you'll have an x-intercept at positive 8 and an x-intercept at negative 8. And it'll scoop down. Alright, number 2. The problem with number 2 is we don't have our x squared term isolated, so we have to get rid of 5. Since we're subtracting, we're going to add 5 to both sides. We're left with x squared equals 25. We'll square root both sides, putting the plus or minus in front. 25 also happens to be a perfect square, so x is going to equal plus or minus 5. We'll go ahead and circle those answers. The more work we have, the harder they are to find. Okay, number 3. I've got x squared plus 36 equals 0. I've got to get x squared by himself. I'm going to subtract 36 from both sides. I'll have x squared equals a negative 36. Now when I go to take my square root, I'm taking a square root of a negative 36. I'm not taking a negative square root of a positive 36. That negative belongs to the 36 term. And as you remember, we cannot take a square root of a negative value. And if you try to put it in the calculator, square root of negative 36, it will give you non-real solution or something along those lines. Something that'll key it off that there's something wrong here. So in this one, we'll have no solution. This parabola in particular will not cross the x-axis. It's going to be hanging out way up top. Okay, moving on to number 4. Now number 4 will look a little bit different. Good news is it's not difficult at all. The x minus 1 is a binomial. The whole binomial is being squared, so my squared term is by itself. So we can go right into taking the square root of both sides. Square root of the squared term is just x minus 1. Square root of 49 will give us a plus minus 7, because 49 is a perfect square also. We'll add 1 to the other side. I think it makes it easier if you put the 1 in front of the plus minus 7 to keep your sign straight. So x is going to equal 1 plus minus 7. Now since you can simplify this, you have to simplify it. So spread it up into 2 separate equations. You'll have x equals 1 plus 7, which will give you 8. And then the other side of it will be x equals 1 minus 7, which will give you a negative 6. And those will be your 2 solutions when you go to graph. Number 5 is a little different. My x squared term's not isolated, so I have to get rid of 6 first. Since it's being subtracted, we're going to add it. Well, x minus 1 quantity squared. 6's cancel. 3 plus 6 is 9. Now we can deal with the square root, and we'll square root both sides. We're left with x minus 1 equals plus minus 3. Again, 9 being a perfect square. We're going to add 1 to both sides. So we have x equals 1, positive 1, right? Plus minus 3. Split it up. We'll have x equals 1 plus 3, which is 4. And we'll have x equals 1 minus 3, which will give you a negative 2. So your 2 solutions here will be positive 4 and negative 2. Alright, number 6. Last one for the square root method. It looks like I might have my term isolated, my squared term isolated, but I don't. That 5 is being multiplied by the quantity x plus 3 squared. So we've got to get rid of 5 first, and since it's being multiplied, we're going to divide it out. 5's are going to cancel. We're left with x plus 3. Again, quantity squared. 20 divided by 5 will give us 4. Square root both sides. I'm left with x plus 3 equals plus minus 2. Then we'll bring over the 3. Since it's positive, we're going to make it negative on the other side. So I'm going to kind of skip a step here. So x will equal negative 3 plus minus 2. And now when we go to split it up, if you mental math it, negative 3 plus 2 will give you a negative 1. Negative 3 minus 2 will give you a negative 5. So your 2 solutions here are negative 1 and negative 5. Again, we split it up, negative 3 plus 2 and negative 3 minus 2. Okay, turn to the next page. The U-tries on top we'll do tomorrow in class, and we'll move on to factoring. Now again, we've done factoring in class, and these are all pretty simple trinomials, meaning 3 terms. So what we're going to do is do a quick review. When you have a trinomial, we try to unfoil. My students seem to like that terminology. So we want to break this up into 2 different sets of parentheses known as binomials. And how you do that is you take the last term and you say, okay, what 2 numbers multiply to 10 and add to 7? Do you remember coming up with the Ma chart? What multiplies to 10 and adds to 7? Well, in this case, the only terms that come to mind would be 5 and 2. Both positive, because if you add them, oops, my bad, both positive. If you add them, you get the positive 7. If you multiply them, you get the positive 10. So when you break them up, you'll have x plus 5, x plus 2. And if we were to FOIL this, we'd get that original problem. Then what you need to do is break them up and solve for both x's. So you have x plus 5 set equal to 0. You have x plus 2 set equal to 0. We're going to move our 5 to the other side. So you'll have x equals negative 5. Again, we'll move 2 to the other side by subtracting it. And we'll have x equals negative 2. And if we were to graph these, we would have a parabola with an x-intercept at negative 2 and at negative 5. And this one just happens to open upward as well. So that helps you graph them. Alright, now the second problem. We've got x squared minus 10x plus 25. Simple trinomial again. We're adding and we're multiplying. The big difference here is my 25 is positive, but my 10 is negative. So I have to rack my brain. Well, not too hard. The two terms that always come to mind for 25 would be 5 and 5. And in order for me to add them together and get a negative 10, they'd both have to be negative. And if I multiply them together, I would get the positive 25. So we could drop down into our parentheses, x minus 5, x minus 5. And then when you go to split these two up and set them equal to 0, you're going to get the exact same answer, but twice. And that's okay, even though we have a quadratic and we are looking for two solutions. Remember, it's possible to have just one solution. So we'll add 5 to both sides, and we'll get x equals 5, and go ahead and circle that answer. You don't need to list it twice. If you were graphing this, you would see your parabola come down to 5, touch on 5, and then head on back up. Okay, number 3, trinomial again. Again, we want to multiply to the last term, negative 32. We want to add to negative 14. 32, 8 and 4 usually come to mind, but 8 and 4 won't get me to 14. 32 and 1 is out. I won't get anywhere near 14. But 16 and 2 might get me there. And if I make the 16 negative, when I add them together, I'll get a negative 14. Again, right into parentheses, so I'll have x minus 16 times the quantity x plus 2. Set it equal to 0. X minus 16 equals 0. When you split them up, x plus 2 equals 0. You'll get x equals 16, and you'll get x equals negative 2. I sort of skipped a step there, but adding 16 to both sides will give you 16. Subtracting 2 from both sides will give you a negative 2. Okay, that's a quick review of factoring. And then, finally, we're at the quadratic formula on the last page. Remember, quadratic formula, it's helpful if you have it memorized, negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And when you're using quadratic formula, your equations must be in standard form, which is ax squared plus bx plus c equals 0. Okay, so looking at my first equation here, okay, this doesn't look so bad. It's already in standard form. I can identify a, b, and c. So a is 1, b is positive 7, and c is positive 10. So we're going to plug it into our formula. Negative b, so it'll be negative 7 plus minus the square root of b squared, so we'll have 7 squared minus 4 times a, which is 1, times c, which is 10, all over 2 times a, so it'll be 2 times 1. And then we just start simplifying from there. So start with what's on the inside of your radical. Leave your negative 7 alone. We'll have negative 7 plus minus 7 squared will give you 49. And then 4 times 1 times 10. Careful your signs. It should come out negative because I have 1 negative, 2 positives. And 4 times 10 will give you 40. And then you can simplify the bottom 2 while you're at it. 2 times 1, 2. Okay, we can take this a little bit further. Still looking at what's on the inside of your radical, you'll get, bring the negative 7 over, plus minus 49 minus 40 is 9. Thankfully it's a perfect square, so it'll make the math easier. Bringing it down one more time, we'll have negative 7 plus minus the square root of 9 is 3, all over 2. Now here's where we have to split it up into two separate problems. We'll have negative 7, we're going to run out of space here, negative 7 plus 3, all over 2. And the second problem will be negative 7 minus 3, all over 2. This will give us negative 4 over 2, which is negative 2. And this will give us negative 10 over 2, which will be negative 5. And I think I saw those two solutions somewhere else, because this is a factorable trinomial. So notice that if you factor or use quadratic formula, you'll get the same solutions. So if you recognize it as factoring, you like factoring, do factoring. If it says use quadratic formula, I'm kind of stuck. Use quadratic formula. Okay, letter B. This one's a little different, not in standard form, so the first step we have to do is take the 10 and move it over. So we have 2x squared plus 7x. Since it's a positive 10, we're subtracting it from both sides. So we'll have minus 10 equals 0. We have A is 2, B is 7, C, careful, is negative 10. So putting it into your equation, you've got negative 7 plus minus square root of B squared, so we'll have 49 minus 4 times A times C. So 4 times 2 times negative 10 all over 2A. A lot of times we're just used to putting 2 times 1, but this A is 2, so we got to do 2 times 2 on the bottom. Simplifying from there, bring down your negative 7. Take care of what's on the inside. I already did the 49. I'm jumping ahead. And now here, I stop and I look at this a few different ways. I've got negative 4 times 2 times negative 10. I have a negative times a negative, so I'm going to have a positive. Okay? I've got 4 times 2, which gives me 8. And then 8 times 10, that'll give me 80. So I have plus 80. And then on the bottom, 2 times 2 is 4. Okay, still simplifying my radical. I will have negative 7 plus minus 80 plus 49. It's going to give us 129. Oh, good. Not a perfect square. All over 4. So what we want to do next is use your graphing calculator, or whatever calculator. Try to pull up what the negative, or what the square root of 129 is. And depending on how you put it in your calculator, you could just do parenthesis, negative 7 plus second square root 129, end it. Okay, now that just ended your parenthesis for the 129. Now we have to end the parenthesis for our numerator and then hit divided by 4. And we get 1.089, blah, blah, blah. Okay, 1.089. Now we have to put it in again for the minus, so you can just hit second enter. Everything comes back up. Arrow back, change that sign. So now we're subtracting the radical. Hit enter, and we get negative 4.589. Okay, there's your two solutions. Alright, one last problem, number 3. Again, we're not in standard form, so we have to bring the 5 over. So we have negative 4x squared minus 7x. 5's positive, we have to make it negative. A is going to be negative 4, B is going to be negative 7, C is going to be negative 5. So we have negatives all over the place. Now, when you do negative B, you're going to have a double negative here. That's from your formula, and then you plug in negative 7. Plus minus square root of negative 7 squared. Make sure you use your parentheses here. Minus 4 times A times C. When you do that, you have negative 4, because you have minus 4, times A, negative 4, times C, negative 5. All over 2A. So all over 2 times negative 4. Let's simplify it a little bit farther. So you have double negative on 7, make it a positive. Plus minus, we are squaring a negative 7, so it's a 49, which is positive. Then you have a negative times a negative times a negative, which is going to give you a negative. 3 negatives give you a negative. 4 times 4 gives you 16. 16 times 5 should give you 80. And it's going to end up being negative. If you ever get confused, you remember with multiplication, you can switch the order around. So you could also do 5 times 4, get 20. 20 times 4 will give you 80. Now I see something right now that's hopefully going to make my life a little bit easier in a minute. And in the denominator, 2 times negative 4 will give you a negative 8. Our next step is to simplify the radical. But I can see what's going to happen here is 49 minus 81 is going to give me a negative value. Or minus 80, I should say. And my brain is thinking ahead. So I'm going to be trying to take the square root of a negative 31. I can't do that. This is going to give me a non-real answer. So for this one, I won't have any solutions. Anytime we get a negative in that radical, we're done. Our parabola is not crossing the x-axis. Okay, if you have any questions, write them down. I know there was a lot in today's lesson. Hopefully it's review for most of you. We'll see you tomorrow.